Okay, method overriding. If you haven't seen the previous tutorial on inheritance, then I highly suggest you watch that because it follows on from that. So what I have here, I have a basic animal class. We're giving the animal class a name and an age. And now I have a dog class. And again, the dog has a name and an age, and also a cat class right here. And they do various things. So with the animal, I'm saying the name, age, and making a noise. Same for the dog, and same for the cat. So if I go to my animal class here, we have the usual things, the methods from the last tutorial, but also we have one more method here, and it's called make noise. And all it does is echoes something to the screen that says makes random animal noises. I have a dog class that inherits from animal, so it inherits all the public functionality we have defined here, and a cat class that also inherits from animal, but they do nothing. The cat and dog classes are doing nothing right now. So if we run the program, so you can see here, my name is Henry, I am 5 years old, makes random animal noises. And it does the same for the dog and the same for the cat. So what we're doing here, we're inheriting all of this functionality, but you can see in particular we're inheriting this method here called make noise. Now this is part of the animal class. For instance, we might not know what kind of animal we have, so we just have a generic animal called Henry. However, in my dog class, well, I know that dogs bark, for example. So Lassie here, I would want Lassie to bark. I don't want Lassie to make random animal noises. Same with the cat class. We have Felix. I would like the cat to meow, for example. I could easily do that by defining a new method here called bark in the dog class. And then in the cat class, I can define a method called, make noise or purr or meow or something like that, which is unique to a cat. But what we can actually do is override this method here called make noise. And what that means is we can inherit this noise functionality, but it's not going to do this, it's going to do something else. And that something else we can define in our child class, for example, the dog class. So how do we override this method? How do we inherit this and override it? Well, in the child class here, dog, we're already inheriting the method already because we're making random animal noises. But we want the dog to bark. So how do we do that? What we have to do in the parent class, so in this case animal, we need to make the method what's called virtual. And what that is, it's a new keyword called virtual. And that just says, okay, anyone inheriting this class, you can give your own definition to this method if you want to. It's your choice, you don't have to. So right now, I'm not even doing that. I run the program, I'm inheriting all this functionality. So virtual is basically saying, okay, the option is there to redefine your own content for this method. It's optional, you don't have to. So that's virtual. But what we want to do, yes, we do actually want our own functionality. So for example, in this child class here, dog. So what I want to do, when I call the make noise method here, I want to bark. I want the dog to bark. So in order to do that, I say bark or woof, or maybe both. Why not? So I've copied this method from above, but we don't put virtual here. We use a new keyword called override, and that's again a special keyword. So in the base class, the parent class, we use the keyword virtual. In the child class, we use the keyword override. That is basically saying, okay, I'm inheriting this method from the parent class animal, but I want my own definition. I want to override your kind of logic and put my own. So override always goes in the child class, in this case, dog. And in the base class, we have to set it to virtual. If we don't put virtual, then we can't override it. So they kind of go together like a pair. And in our cat class, well, I want the cat to meow, for example. So there, it's as simple as that. So if I run the application now, You can see here, my name is Henry. Now, Henry is a generic animal. He's not a dog or he's not a cat. So Henry makes random animal noises. However, Lassie, well, Lassie is a dog. So when we call the method make noise here for the dog, then the dog is going to bark and woof. The cat, well, the cat's not going to make random animal noises because the cat class also overrides the virtual method make noise, and the cat is meowing. So you can see that's quite a basic example on how we can reuse this method here, make noise, which is defined in our parent class, but give our own definition to it. So this is reusing existing code like this method here, but we don't want this kind of functionality, we want our own. And the process of defining our very own definition is an example of what's called polymorphism. What is that? It's a Greek word that means many forms or many shapes, but it's a key principle of object-orientated programming. So you've been doing an example of polymorphism this whole time, maybe without realizing, but this is the key principle of OO programming, and it's very important. And like you've seen already, it's achieved through inheritance and reusing code, but not only that, but providing your own definition for something. So this is polymorphism. So this is an example of method overriding in C#.